In this video, we're going to take a look at what I consider to be my most brilliant creation, the Object Mover. And let's open it up. And we start with attaching world objects to our scene component. So the whole principle is based on the same logic of the doors. We are using move component 2. And here we are attaching objects in the world to our component. So when we move our component, those objects move with it. There is no other node like move component 2 that can move objects over time. So in order to move the objects outside of the blueprint, I came up with this method. So first of all, we check if our variable is valid and then attach it to the scene component. Now we have 4 by default, and you can have as many as you wish. Start opened. If we start opened, right, if we set this variable to 1 by default, then it will open on event begin play. And this is also important for save games. Next is the trigger. And here we have 2 options. First, we have a variable here, trigger, that is a volume, the trigger volume. And when this is valid, so when we have specified a trigger volume in the world, then we bind event on actor begin overlap, and we cast the first person character, and then we open it, and we do this once, and this resets after the thing closes. Here, if this is not specified, we can use self trigger. If we set self trigger to 1 here, then this little box here will be our trigger, and we can of course change its volume. However, note that if we specify this one will override this trigger, even if we set it to 1. And next is the main part of the logic. So close logic is basically the same, and as you can see, we first stop each of the movement in the logic. We set our open close state to 0 and move component to 0 location and rotation over the time, move time, that we can also enter here. This logic uses move direction and move direction 2. This is move direction 1, right? This is move direction 2. And this logic uses our targets, these 2 variables. So we can specify target point and once we've done that, this logic will override this logic. Here we check if move 2 is valid, and if it is, it will go to this part of the logic instead of this. Both of the logics uses the same move rotation. So we can take a closer look. We set open close state to 1. We check if this is valid, if our target is valid or not. If not, we're using our move to direction, we move the scene component, and we have relative location for the scene. Plus move direction. Then if our then we have a delay that is equal to loop delay. We can specify it here. After this delay, we need to check if we are still opened, because if we closed it, we don't want this to go on. And here, this will happen. The second point, the second movement will happen if we set one of these values different from 0. So if you really want it to be 0, you can make a small value and it'll start to work, so that we don't have an additional variable switch to make it work. So once we changed the value of move to direction or move to rotation, this becomes active. And then again loop delay, and we check open close state, and if we're still open, we go to the loop. From both of these parts, we also come here and check if close option is enabled. And if it is, after the close delay, we close it. Since we don't have a direct way to open it, we don't need the timeline here. And the switch got its logic on its own. So move to target. When we close, by the way, we also check if these are valid, otherwise we get an error in the output log. So once this is happening from here, right, we also move the same component. We use the same rotation, move rotation and move time. However, we get the world transform of the default scene root and use this inverse transform location to convert world space to local space. So for the target, right, we need the location of move to actor, which is the our target point. However, the location of our target point will be in world coordinates, and we are moving everything in relative location, so we need to convert it. So we are converting world location of move to actor to local space relative to our default scene root. The rest is basically the same as here. We check, we get the delay. We check also if we are still open. And then if move to is valid, we use our second destination. So it happens like this. You can see the loop. Also, the loop, of course, also has open close state check, and it checks if loop is enabled here. And basically this is it. Now you have to make sure that static meshes are set to movable if you want to move them. And obviously, since we are moving this component, it will be our pivot point. If you want it to be right in the center of the object, you can select the object, copy its location, select the mover, paste it, and it will appear right in the center. it will be a little bit difficult to select it this way, so you can adjust the size of the trigger box, which is not being used, which will not be used probably in this situation. And this way you will have the pivot point in the center. In case you want to simply bring it to the side, down, for example, or up, it will not really matter where you place this. Yes, since we have specified our target point, which is here, it was moving here along, and this was moving along. So if we deselect this, this will start to play, and it will go down. Oh, and of course, our switch has an option to operate the object mover. Also, I have this BP wall here. This is very simple. There's nothing really inside. However, you might want to expand and add values um, and add some logic if you wish. I made this so that you have this box collision that is set to be dynamic obstacle. Because this will sometimes it's fine, but you see other times it goes through us. Also, we simply move it. You see? So it kind of works, but not really. So depending on how you want to use it, you might want to have something that has box collisions. Yes, box collision. As you can see, this works a lot better. And in the next video, we will take a look at another ObjectsMover, which is based on timeline logic.